Okay. All right. Yeah. So I said it last time, but we just wrapped up chapter 1. So we have that logic worksheet that we worked on. That's fairly long, and I said it last time. But if you need a little bit more time on that, uh, I think I said what, Friday or something like that. I'll probably be grading it next week, to be honest. Um, so you can spend a little bit more time with that thing and look over it. That's something that's putting everything together, right? It's kind of wrapping everything up in that chapter. So it is a bit of work. Yeah, I want you to do the whole logic worksheet. There should be like one part on the first part, there should be like one part on the second part, and there should be like two little arguments that you got to finish up on that last part. And if you need help, I will be in office hours today for an hour after class. I think class ends at what, 9:35. I'm in my office from like 9:45 to 10:45. So if y'all want to come by office hours and you got questions about that, I would definitely be there for that. I know it's quite a bit, especially the last part, right? It is pretty involved, but I think it's doable, right? With enough, and especially with enough practice. This is the practice. This is the stuff you're allowed to mess up on. Hopefully, by the time we get to the quiz, you'll get that stuff just nailed down and you'll know it. That's what I'm hoping. And then we get to the test, then you'll definitely have it down. With that said, I think I have a plan for the quiz. So we have a test in a week, and you have a quiz that goes along with that should get turned in before the test. So hopefully you'll be working on that thing a little bit. I think you can do most of it. You can do all the first section over logic. There might be some stuff on geometry. Being honest, you might still be able to do most of it. Uh, what was I going to say? So with the quiz, what I think I'm going to do is I think I'm going to put up a correlating sort of quizzes exercise to go along with it. So it can give you a little bit of I want to say a little bit of direction to make sure you're going and doing things correctly, I guess. With that said, I think I should have that probably up by the end of like today or tomorrow if I'm doing things correctly. If things go according to plan. So hopefully it should be up probably today or tomorrow, and I will try to send that in an email to everyone, let y'all know. But I think that's the best way. I figured it out last night, I guess. Any questions about what we've done, what we're going to do, what's planned? It feels warm in here. I don't know if it's just drinking warm coffee. About to get into some heavy math. Ooh, all right. First problem. We want to find the perimeter and area of this thick guy. Ooh. So I think I've got this broke up into separate slides after this, like find the perimeter, find the area. I just wanted a nice big picture. So I talked about this in the notes. And so the sort of thing that I really like about math is you don't have to trust authority, right? I don't know how else to say it. You can see these things for yourself, right? So to speak, like the axioms are self-evident, and everything is built off of the axioms, like deductively. So if you want to find the perimeter of this thing, and all I'm looking for is a number here. So how do I find the perimeter? What is the perimeter? we awake? Where are people? How do these pictures look on your phone when you go through these? They look decently sized on this. Okay. Yeah, I did the picture large and separately in some of these little slides. But it looks decent when you go through it on your personal device. Man, this should not be taking that long. We got 2 people here. Come on. All right, so what is the solution for this thing? What was the perimeter? Is it there? Come on. We're going to go around the outside of the object is what the perimeter is. So if we do 5 plus 5 plus 8, that should give me 18. If I were to guess, you probably said 21 or something like that. So there's also that 3 in the middle, but that is in the middle. It is not around the outside of the object. All right. And then the next thing is area. So how do we find area of this thing? There is a formula. Does everyone remember the formula? Does anybody not remember the formula? I remember I derived it sort of in the notes, right? Does anybody want to talk about the formula?
It's half base times height.
Base times height. So yeah, that's it. So that helps. And we like started with a square, right? If you do a square, it's what, like base times height? And then if you take like the diagonal down the middle, you could argue that that's half of that square. So you're going to have about half the area. And then if it's not at a perfect right angle like this, we can do some shifting around. We can move things over and stuff. And we can make it a square. All right, where are we at? Ooh, what'd y'all do? Let's see. I'm more curious as to what did y'all said, that 112, 21. I think you flipped your numbers there. I don't know what you're doing. 24. Oh, look at this. That's base times height, right? So you still have to half it. So, okay, that's good. So what we're doing is the base and the height. So you need to find 2 things that are at like a perpendicular. That's what they mean by the height. We have a base here. We have the height that's at a perpendicular going from this side to the alternative angle going over there. And so the base and the height are 8 and 3. 8 times 3 is 24. We're going to divide that by 2 because we have to half it. So it should give you 12. A picture window has a length of 8 feet and a height of 6 feet. And they give you a little picture over here with a semicircular cap on each end. How much metal trim is needed for the perimeter of the entire window, and how much glass is needed for the opening of the window. And I think we might have to use pi in here. If we ever use pi in here, 3.14, I think should be good for everything. I don't think there's anything we got to get more specific on. Okay. Did I put a slide in here describing this one? I hope I did. I don't remember doing it now. How much metal trim is needed? Let's see if I remember how to do it. And I think I tried to put it in there. If you just put a number in there, I think it should count it correctly. If you put the number in and you put an abbreviation for feet, I think I try to put that in there. If you put the word feet, I think I try to put that in there. So if we go around the outside of this object, they don't want to know about the inside trim. I believe what they're asking for is just the perimeter here. And so if we go across here, this is going to be 8 feet. This is going to be 8 feet. So that's part of it. And then what else do we have to find? What is that called? What is the perimeter of a circle called? We don't call it perimeter. Someone said it, and I think I spoke over you.
I said the circumference.
Yeah, that's it. Circumference, right? So circumference is like what?
The equation for it?
Yeah. What's the equation?
It's pi times diameter or 2 pi r.
Yeah, you can do pi times what they're giving us here is the diameter. So it might just be easy to just go pi diameter, right? Or you could do 2 pi r is what we usually do. Yep. So we got what, 8 and 16 plus, what is that, 6 pi, I believe, for this perimeter. Is that what y'all did? Again, it's 34, what is it, 34 point something? $22.2. Did I do it right? $40.46, 34.84. Oh man, y'all are all over the place. Are there any questions about this? I mean, there's like,
I have a question. Once you get your answer, after how many decimal points do you have?
well, if you did it like what 3.14, I think you're gonna only have like 2 decimal places.
2, okay. Thank you.
So yeah, usually like 2 or 3 decimal places is usually pretty good. And if you don't do it with rounding, it's like what? 3.85 if you did it with the pi, right? I think without rounding. Okay. 3 people still hadn't answered. I'd like. Oh, for some reason, it didn't count mine right. Maybe I didn't round it up, and that's probably what I did. Usually, if it's a rounding issue like this, that's what I did. 34.85, 34.84. It's correct. I'm not going to count off for a couple, like a rounding issue like that, to be honest. How much glass is needed for the opening of the window? So you should know your units. I'll tell you that, right? But if I'm being honest, I think I put all the solutions in this quizzes to where you could just type in a number. But that first one, if we're doing perimeter, and this is measured in feet, what is our perimeter going to be measured in? What's the units on our perimeter? If our distance is in feet.
Feet.
It's also in feet. What's the units on my area, which is what we're doing now?
Feet squared.
Yeah, it'd be square feet or feet square, feet with the little square symbol. So we're doing a two-dimensional sort of like measurement. It's like how many feet by feet square will fit into this object. It's kind of like what you're asking yourself. Okay, so what's the first thing you're probably going to take the area of? What's the easy thing to take the area of? We'll break it down a little bit. What's the first object here you're going to take the area of?
The rectangle.
The rectangle. It's a 6 by 8 rectangle. That's going to give you what? 6 times 8 gives me 48. It's just base times length times width, right? Base times height. Oh, I'm going to put that on silent so that's not disrupting me. Okay, so that is 48. So we have 48 and we still have to add what? This little circle thing. So I know there's like a rectangle in the middle, right? But if you like erase this rectangle and you just squeeze the two ends together, it makes a whole circle. And I think you'll recognize that or looked at it in the previous one probably and saw that. But I want to find the area of a circle. What's the area for a circle? What's the formula? Someone got it?
Did you say area?
What was that?
Did you say area?
Yeah, the area of a circle. What do we do for that?
Pi r squared.
Pi r squared. So my r here is not 6, it is 3. So that's something you have to do. But I want to do pi r squared. So I believe we're adding 9 pi to 48. I think is what it ends up doing, right? And if we do that, are we getting something? Ooh, he's looking a little bit better. 48. 48's half of it. We still got to do more. Okay. Okay. And this is in square feet or feet squared. Do you want to proceed? Yes. Did I not get it correct? What do I do? It's like a rounding issue or something, huh? Whoops. Close enough. All right, so this is the figure that they're talking about. Show this region. So they want to take this figure. This was a figure from the book or whatever, from the lesson. And now they're reusing it for one of the homework problems. And so now they're taking this figure that they used from the lesson and they're saying, suppose the stairs rise at a steeper angle that are now 11 feet tall. What is the area of the region that to be covered in that case? And so we're going to strike out what and put what where. Like, what are we crossing out and what are we putting?
You're
Put
crossing
a
out the
number
9.
instead of 9.
Crossing out the 9 and putting that 11 in there. All right, there you go. So what is the area? What is the formula for the area? Is that what I have next, I think? I think the formula for area is what I put next. If I want to do the formula for the area, it is how to find the area of this thing.
Is it 1/2 base times height?
That's exactly what it is. 1/2 base times height. So 1/2, what, 12 by 11? If I have 12, that gives me a 6. I believe it's going to give me 66 square feet. Any questions about this one? I feel like this one is like, I feel like they just put a picture in here just to like, just to make it a word problem or something. I don't know, man. It's just like, it's pretty simple. Find the area of this triangle sort of problem. All right, so now we're looking at this thing. It is a parallelogram. It is bounded on 4 sides by a street. How much asphalt in square yards is needed to pave the parking lot? So how do we find the area of this thing? I don't know if I have a slide for that.
Is it base times height?
It is base times height. So what is that? 150 by 180? I believe it gives me what, 27,000? 27, yeah. Did I make a slide? Maybe I did make a slide for it. There we go. Giving you all the information away. And I think I put commas to indicate the thousands place, right? Every 3 digits. You know, in certain countries, they do things a little bit backwards, right? Or I guess it's not backwards, reverse from what we do it. They'll put periods or decimal points every 3 places, and then they'll put a comma where the decimal spot goes. I know in France, I believe the French do that. But they reverse their commas in their decimal places, in their digits. Where are we at? Are y'all answering this? We just talked about this. If y'all just put in a number. All right, we're going on. Where did that? It didn't show me the results from this one. What is going on? There's 9 people. I guess I have to end the question. That's weird. I can't just go to the next slide. All right, fine then. You know, sometimes you learn by doing the wrong thing. There we go. Usually you learn by doing the wrong thing. Usually you don't learn by doing the right thing. Yeah. A water reservoir. The water reservoir for a city is shaped like a rectangular prism, 250 meters long, 60 meters wide, and 12 meters deep. At the end of the day, the reservoir is 70% full. How much water would you need to fill it with to make it full? Something along those lines. I don't know what it says. It cut off. Okay. How much water must be added overnight to fill a reservoir? That's what it says. So this one is a bit more probably involved. All right, so I will walk you through it probably a little bit, but I want you to give it like a good, honest attempt. It's me. I can't see because the stupid slide thing's in the way. Oh, that is me. I guess I'm a little lamb. All right, so what do you have to do? What's the first thing you're probably doing on this?
Finding the area.
Not area. We're up one more dimension.
The volume.
The volume. So find the volume. We got these three things. It is a rectangular prism. So you might have to know what to do with rectangular prisms in order to find their volume. And we know at the end of the day, it's 70% full. So then we have to do something there. There's a few different ways to think about it, and if I'm being honest. There's a few different correct ways to think about it. There's also a few different incorrect ways to think about it. So let's make sure we're getting on the same page. If the reservoir is 70% full, and this is what I did. If it's 70% full, how much of it's going to be empty?
30%.
30%. So how much are you filling up? You're filling up 30% of whatever volume you have here. So your answer should be in, what's your unit on your answer? This is meters, meters, and meters, and we multiply them together. What are we going to get?
Meters cubed.
Cubic meters, right? Yep. Cubic will be in cubics now. So volume is like cubes. How many cubes can we fit inside of this object? So take the volume of this thing, then figure out what 30% of that volume is. And I think I'm going to hit the end. I know a few people still haven't answered. So you're probably going to want a calculator today, in case I haven't said that already. And like on most days, right, when we're doing calculations and stuff, I guess that first chapter was logic, so there wasn't a whole lot of calculations that you need a calculator for. But it's not like you're going to walk around with a calculator in your back pocket. So anyway, the water reservoir for a city is shaped like a rectangular prism. So it should have been 54,000. Going over that a little bit, this is the picture that I have in my brain from that previous problem. We know we have some sort of reservoir. These are the dimensions of it. We know it is what, 70% full at the end of the day. So that tells me that I have 30% left here. I want to find the area of the whole figure. I go 12 by 250 by 60. That gives me 180,000 cubic meters. I want to find 30%. So if I had to guess, I hope you got this far. If we want to find 30%, I don't want to multiply by what, 30. I want to convert this to what?
The percent to a decimal.
Yeah, convert it to a decimal. So I have to move it 2 decimal places. It should make it what, 0.3? If we take 30% of 180,000, that should give us the 54,000. The word of, right, usually indicates multiplication. So if I do 30% of, that means I take 30%, convert it to decimal, multiply it through. And we will go over a section like later where we talk more about percentages and stuff. And there's, like I said, there are a few different ways to do this problem, to think about these concepts. So that's why I ask if you got questions. I can always try to figure out another way to explain it. But if you don't ask, I don't know, and you don't know, and then no one knows. So suppose you build an architectural model of a new concert hall using a scale factor of 30. How will the surface area of the actual concert hall compare to the surface area of the scale model? And so this is really trying to get at that dimensional analysis. And this concept, I will say, you should be aware of it in this chapter. I'll give you a little bit more of an explanation when we get to unit analysis in that chapter in unit analysis. This concept will come back up and you'll get a little probably reaffirmation into like why it's a thing. Why are we doing this? But if you're thinking about this, a scale factor of 30, meaning, and there's no units on this, right? You could go 30 feet here, means you'd be going 1 feet on the actual thing. Or if you go 30 feet on the actual thing, you'd be going 1 foot on the model, right? Or if you go 30 meters in the actual thing, you'd be going 1 meter on the model. It gives you a ratio. These things are, I want to say, they're similar, right? Like similar triangles. They're the same shape, just different sizes. Kind of like you zoom in or zoom out. You're not changing the actual object. You're just changing like the size of it, right? So if it's 30 feet here to 1 feet here, if we get to surface area, let's assume this is in feet. Let's just keep it with feet. So if it's like 30 feet to 1 feet in a length, this is feet to feet. What is surface area measured in? What are the units on surface area? On area, or it's a sort of area, right? If our length is measured in feet, our area would be measured in
What was the question?
Square feet.
square feet, right? And so there's a little bit of a thing that happens here. We don't have this once, but we have it how many times?
30.
I was thinking like going from feet to square feet. There's 1 feet here. There's two factors of feet here. So we actually have this factor twice. Since we're going from feet to square feet, this factor is occurring twice. So we're not doing 30, we're doing 30 times 30, right? So you got to do 30 times 30. You got to do 30 squared since we're going from feet to square feet. You also have to square this number. All right. So I just told you what it was. So hopefully, hit it real quick. Should be 30 squared, right? Which is what? Did I not get it correct? Oh no, that's the correct sound. Never mind. That's a happy chirpy. It should be 900, right? 30 times 30. So we also have to square the conversion factors. This also happens when we go from like what 3 feet is 1 meter or 1 yard. Sorry. 3 feet is 1 yard. If you're going from yard squared to feet squared, it's not 1 to 3. It's going to be like a 1 to 9 sort of thing happening, right? All right, so now we're doing the same sort of thing. This is the same thing happening. If I go from feet to square feet, I also have to square my conversion factors. If I go from feet to cubic feet, guess what I got to do?
Times 3.
Not times 3. It's to the third. I'm glad you said that. There's a difference, right? Between multiplying by 3 and raising something to a third power. That is like such a common mistake. I'm so glad you said that. I'm just being honest. Like, I'm glad that got brought up. So this is a factor of 4. So what do I have to do with that 4? What's it going to look like? 4 times
4 times 4.
That's exactly it. We're going from a length factor of 4, right? 1 to 4 is what this factor is. And now we're going from length to weight. And they don't really say it in here, but weight, is that going to be based off of length, area, or volume? It might be a little tricky on that one, huh? But weight is definitely based off of which one?
Volume.
Is definitely volume, right? Is definitely measuring how much volume you got. So by what factor has your weight increased? This will be by the same factor your volume increases. That's what they're asking here. So I think we've said it enough, but it's 4 by 4 by 4 is what we should be looking for here. Oh, look, you draw. All right, consider a person, Sam, who is 20% taller than you and proportioned exactly the same way. That is, Sam looks like a larger version of you. So they try, I think this is the one where they asked you for your waist size. That's like a personal question. Like, I don't know why. I don't know. I find it kind of funny. Assume your waist size is 39.7 inches. Just so we have something that's common. And we want to know, what is Sam's waist size? Decimal. I think this one gives you something to 2 decimal places if you do it. And this is one of those like percentage problems. We get a little bit more into like how to do these percentages in a later chapter. So how would you do this? And there are a few different ways. how'd y'all do it? That's what I want to know. Did y'all find the what? The 20% first, or did y'all go a different route?
So we were supposed to include the 20%, because I included it the first time, but then it says that he's just 20% taller.
Yeah, so there's
but that
20%.
they're but that they're proportion exactly the same.
Mhm.
So
So what size is Sam's waist? If he's 20% taller and it's proportioned the same way. So if his height is growing 20% and it's like the same proportion, what does that mean about your waist? Your waist also has to grow what?
okay, 20%.
Yeah, it's also growing 20% to stay in proportion. So how do you increase 39.7 by 20% is the question. Did anybody say 7.94? Did anybody get that solution? Because if you did, you're halfway correct.
Yes, but that means you add it with the 39.7, right?
Yep, that's one way to do it. Yep. So if we take 20% of the 39.7, that's going to give us the 7.94. If we go add that back to the 39.7, I think we're almost there. I'm going to hit it because I'm kind of telling you what to do. Who's chatting? By 0.5 instead of 0.2. Okay. And then you're going to increase them by what, 150%? Do you want to proceed? Yes. Wah, 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 wah. So you can take 20% of the 39.7 and then add it back to the what, 39.7? Did I do this in the next slide, or is it another problem? If it's another problem, I'm gonna pause it. Okay. That's not what I want to do. Just do a Word document. Is this visible in there? I probably got to share it, I think. Here we go. I think y'all can see this now, right? So I'm taking 20% of what, 39.7 was the word? And this is giving me 7.94. And I take this, what, 7.94, and I'm adding it back to 39.7. And this is what I'm doing to get what, the 4764. So this is one way you can do it. You can take the 20%, you can come add the 20% back. But if I'm adding 20% of 39.7 to 39.7, this is like I have one of those 39.7s, right? There's a kind of a sort of maybe quicker way to get at it that might help you in the future a little bit. 39.7. I'm going to also look at this as being what percent of 39.7. So if I have one of them and I add 20%, is that not like 120% of that thing? Do y'all see that? It's like the distributive property, right? It has this thing in common. If I have the 39.7 in common, I have the 1 plus the 0.2, 0.2. And so another way to look at that is it's kind of like you have 120% of that number. So you could also take 120% of it. questions about that? Okay. So that's probably going to come up some point in the future. Squirrels and humans are both mammals. Stay warm through metabolism that takes place in the body. In the body volume, sorry. What does it say? Mammals must constantly generate internal heat to replace the heat that they lose through the surface area of their skin. So in general terms, how does the surface area to volume ratio of a squirrel compare to that of a human being? Is it going to be larger or smaller? Smaller. Is it gonna, there we go. So if we look at the surface area to volume ratio of a human and compare that to a squirrel. They would have, someone said smaller, someone said larger. Should I put you on the ring and let y'all box it out? Judge things by popularity. Is that how we determine whether things are logic? I don't think. Hopefully not. Okay, so if you think about surface area to volume, surface area is how much surface you have or how much like kind of exposed area you have. The volume is actually like how much kind of like mass you have. So it's comparing how much you're exposed to how much mass you have. So if you're out in the cold, who is going to freeze first, the squirrel or the human? Who's going to become an ice pop first?
The squirrel?
The squirrel is going to freeze first, right? And so what is that saying about their surface area to volume? So they're losing more heat faster, right? Which means their surface area has to be what?
Small.
No, surface area is where you're reacting, right? That's the reaction spot. So if you're losing heat really quick, that means your surface area has to be
Higher?
it has to be large, right? So they have a very large surface area compared to their volume. So the squirrel should have a very large surface area. So the surface area is like the reactivity. There's a sort of like example like really comes to my head, and it's kind of a bad, maybe kind of a bad example because like it's kind of relations to addictions, right? But if you think about medicine, right, that's probably a good one to think about. It's like if I have medicine, if I keep it as a whole large pill, it's got a really small surface area to volume ratio. But if I crunch it up in my teeth and make it into powder and dust, it's got a really large surface area to volume ratio. If that helps, then let that help you. If not, ignore I said it, and don't do drugs, kids. I've seen way too many people get addicted that are decent people. Don't go down that road, please. And so the squirrel should have a larger surface area to volume. So if we think about like who's going to become an ice pop first, that might be one way. Next slide. Who's going to boil on the insides first? Going to be the squirrel. If we get into boiling heat or something, I don't know. The other way of that. which means more energy is getting transferred, right? Squirrels and humans both stay warm through metabolism that takes place in the body volume. And so if you've ever had, I had pet rats a while back, Daisy and Peach. And so there's a little bit, if you know about like small animals, the little, I got little shriveling shit. I can't even speak anymore. Shivering, that's the word I was looking for. Not shrivel, shivering. I got two little shivering chihuahuas that kind of prove this one. So which animal must maintain a higher metabolism to replace the heat lost through the skin? Ooh, and this, the ice pop example kind of gets at this, I think, maybe, hopefully. Based on your answer, which animal would you expect to eat more food in proportion to its body weight each day? Squirrels. Moose in squirrel. Do y'all know? That's before my time. There's like a couple revamps of that, the Rocky and Bullwinkle show. You remember that? Have y'all ever seen that? Probably not. Do y'all know about turtles all the way down?
No.
It's like a creation myth, right? I don't remember. I think there's a few different native creation myths that like refer to turtles. It's like turtles were so slow. If you look at turtles and like, if you ever look at like the Never Ending Story, it kind of alludes to it, I think, a little bit. But there's just like stuff that grows on turtles' backs, and so like they're so slow that stuff like grows on their backs, and like a lot of like the ancient societies would look at that and they'd be like, "There's an earth on the back of this turtle," and so they made the conclusion like, we're actually living on the back of a turtle. And then there's this other conclusion like, well, since there's turtles on this turtle, then maybe there's more turtles. Does that make sense? Like maybe the earth turtle is on another turtle itself. And so maybe then that turtle's on this turtle, and you can go add to, you can go to infinity with that, ad nauseum, right? Or whatever. And you can keep on inductively saying there's turtles all the way down. So if you ever hear someone say turtles all the way down, that's what they're referring to. It's that recursive sort of thing happening. Backyard, we want to look at this thing. It shows the layout. So I want you to give this an honest attempt by yourself at first, and then we will go through it. So let's see if I can do it. And if you use 3.14 for pi, that's good enough. And so maybe I just talk a little bit, maybe. We have the lawn, we have the whole entire lawn. We want to seed it with grass, but we're not trying to put grass seed on our patio or in our flower garden. So we want to know the area of that lawn without the patio and without the flower garden. Squared, and we get minus what, 16. Okay. So I'm hoping in your brain you see the big area and you're like, well, I got to take this big area And then I got to take away this area. And then I got to take away, ooh, crud. I messed up. I'm not getting that one right. So I hope you're taking this big area and then you're subtracting what, the two little areas from it, hopefully. Don't forget that this is a semicircle. I was like, I don't remember this number. That's why I don't remember the number. See, I feel like these are all doable. Like these are all something you should be able to sort of do. This is a testable question, you know. Trying to see where this is 84. The next two, 85 and 87. I do not feel like are test questions, if I'm being quite honest. They are a little bit up there. All right, so I want to give you a few minutes to work through this. Give it a good, honest attempt. And then we will go through it. All right, if you need more time, let me know. I can give you a little bit more time on this one. Skip it. I think two people fell asleep at some point, to be honest. I don't think I got it correct. And if I did, then I got the wrong answer in the other one. So it should be 144.75. Yeah, I got it wrong because I didn't half my circle. So let's look at it. Let's see where we're getting this from. All right, so the first thing, did y'all get this one? Hope y'all got that much. Did anybody not get this, I think? Any questions about where this is coming from? So I want to take the area of this full circle, right, or this full rectangle right here, and I want to subtract the area of this thing, and I want to subtract the area of this thing. So I want to take the full thing first, which is going to give me 200 meters squared. The garden is 16, 4 by 4. I guess I didn't even put in the step of multiplying those two numbers. But you're going to square 4, it's going to get 16. The half circle. So we have to do pi r squared. So pi r squared would look like 3.14 times 5 squared. But we're only doing half of it. So we also have to multiply by a half or divide by 2. Either way you want to do it. We're going to multiply 3.14 by 25 and then half it. And so I think I got my 3 numbers I need. So someone tell me what that next line should say. How do I find the area overall? Is this making sense?
You add the area of the half circle in the garden and subtract it from 200.
Yep, that's it. I think you added these together before you subtracted them. That's fine. That's just like a distributive sort of property happening there. Same thing. We're going to subtract both of those from the 200. And when we do that, should give us that 144.75. And we are talking about square meters. Are there any questions with this one? I feel like you know, this is like, this is a decent problem. Like this and that glass one, right? I feel like these are things that are totally doable for this class. On the other hand, this one is something else. It is a bit much. So I want to go through this, and I just want to talk about like how you would do this. It is a lot of number crunching, if I'm being honest. The human lung has approximately 300 million nearly spherical air sacs, alveoles. It sounds like some Chef Boyardee pasta or something. Okay, but anyway, each with the diameter of about 1/3 of a millimeter. The key feature of the air sacs is that their surface area, because on the surface, gases is exchanged between the bloodstream and the air. And so this is sort of goes back to, like, I guess the pill example, right? If it's a whole solid pill, that's the way you're supposed to take the medicine usually, because it's got a time release sort of mechanism in there. If you need it instantaneous, then you like crunch it up, right, into a powder. And so this is going back to that smaller things typically have a larger surface area to volume ratio. And so instead of having like one large air sac, we have several small air sacs, and they're all like 1/3 of a millimeter. So what is the total surface area of the air sacs? So in order to do this, you have to know what the surface area of a sphere is. This is not something I expect you to memorize. Being honest, I have to go look this up. Like, I don't know surface area of a sphere. I don't know volume of a sphere off the top of my head. So if I do 4 pi, r squared is the thing I need to plug in. What is my radius that I'm plugging in here? And keywords here being what? Diameter of 1/3 millimeter. So what would be my radius? So if my diameter is 1/3, what is my radius?
Half of that.
It's half of it, right? So if I half 1/3, it will give me 1/6. Do y'all know how to do that? Or is that weird? If I take a half and divide by 2, we hadn't done a whole lot with fractions, huh? I feel like maybe a little bit of a let's do this large and in charge. Come on here. Okay. And so if I do one-third is what I was trying to do. So if I do 1/3 and I do what? And I have to divide it by 2. And I'm dividing it by 2. Have we talked about this? That's the same as multiplying it by what? Can y'all see my,
1/2.
yeah, can y'all see this word? Y'all can see this Word document, right? Can y'all see the Word document?
Yes.
All right. And if we do that, right, what is that going to give me? That's going to give me 1 over what? How do we multiply fractions? Multiplying is the easy way to go, right? Adding fractions is the one that's complicated. So multiplying, we just multiply straight through. 1 times 1 is giving me 1. 3 times 2 is going to give me 6, right? And so my radius on this guy is 1/6. All right, so don't lose that. So that's kind of the important, like, sort of thing that we're going to pull off of there. Oh, that should not say 1/3. I think I fixed it. I hope I fixed it. Let's see. 1/6 squared times what? 3.14 times 4. Yeah, that should say 1/6. 0.3489 comes from putting 1/6 in here. Ooh. What slide is this? Because I need to fix this. This is slide 21. All right, making my note. And so the last thing that we're going to do, since there are 300 millions of these little sacks, they want us to multiply by 300 million. So we're going to put 6 more zeros here to make it 1,000,000. And we multiply 300 million by this 0.3489. It gives us something in this one on the left here, that 1.05 times 10 to the 8. That is something in scientific notation. If we wanted to expand it out, it would be 105 million square millimeters. So that is the first part of this thing. And again, this should say 1/6, not 1/3. I didn't fix that. My bad. I definitely calculated it as 1/6. I did fix it with the other number. And so we are on the same question, but now we're doing the second part that talks about the volume. So in order to do that, you're going to have to know what the volume of a sphere is. So this is the formula for the volume of a sphere. We're not plugging in anything differently. We're still plugging in 1/6 to our radius to find the volume. That's the volume of a single sphere. So guess what I'm going to do next? I want to know the volume for 300 million. So I'm going to multiply by the 300 million and get that number. Questions about this? It's really just looking at the formula and plugging in the information that they give you, that the radius is 1/6. To find the surface area and to find the volume. This one, it's an okay question. I feel like the next one is really kind of just like, it really kind of goes beyond maybe what you should be doing in the class, but I don't know. Suppose a single sphere were made that had the same volume as the total volume of the air sacs. What would be the radius and surface area of the sphere? How would the surface area compare to that of the air sacs? So if it has the same volume as the total volume of the air sacs, that is the thing that we found from part A. And so now we're going back, we're looking at that volume equation. We know the volume that we got previously. So the volume that we got previously was this 5.8 times 10 to the 6. And this was with the 300 million sacs. We got this volume. So now we want to know the radius if it was just one sac. And so how do we find that? We find it by plugging it into this volume formula. So we're plugging in the volume we got from the 300 million sacs and trying to figure out what the radius would be if it was just contained within one sac. And so now we're going to have to do a little bit of back solving. We want to solve for r cubed. We want to get this r cubed by itself. So it's being multiplied by what? 4/3 pi. So I think the first thing you got to do is move that 4/3 pi over to get that r cubed by itself. So think about how you might want to do that. I think that's the next page I got going here. We divide by 4/3 pi to get it to the other side. I think it's the same thing as what? Multiplying by 3 pi over 4. Wait, 3 over 4 pi? Sorry. If you do that, so this is what I'm using a calculator for at this point, definitely. I'm getting r cubed is equal to this crazy number. So how do I get from r cubed to r? Does anybody know how to do that? It's a bit of a weird thing, maybe.
Okay, to get from r cubed to r squared.
No, just to get to a single r, you can do it in one step.
You divide by r squared.
Would it be dividing it by r cubed?
If you divide by r cubed, that's not gonna, that's gonna get rid of your r's on this side and just put it over here. This is cube. If it was square, how would you get a square? If this is like r squared equals a number?
You would square root it.
Square root. So now if this is a cube, you're gonna cube root it. Have y'all done cube roots? Or is that a totally new thing?
I think it's a new thing. Are you sure?
You can do a cube root, right? So a square root, you're looking for two things that multiply to the same thing. We can do the same thing with the cube root and higher powers, right? If you can get a variable, if you can get a variable by itself to a power, you can basically do the root to any power to get it by itself. And if we do that, at this point, you're using a calculator to figure out what the heck this thing crunches down to. So maybe a quick calculator check to make sure you can plug these things into your calculator to make sure you can crunch these things. And it is like 9:38 right now. I think we're going over a little bit. So if you got to get going somewhere, I understand. We got like this question to finish up and wrap up, and then like one little piece of a next question, basically. But we're almost there. And so I think the book rounds this up to 112 millimeters is the radius of the big sphere. And so I think we just answered half of this question. I want to know what the surface area of this thing would be, given that that is the radius. So now we take that radius we just found and we go and plug it back into the surface area, I believe is what the second part. Woo! And if we do that, this is the solution we should be getting for plugging 112 into this equation. And so if we had one big sphere with the same volume, this is what its surface area would be. And I think that's the last part, part B. No. They want us to compare our surface area of the big sphere to the little sphere. That's what it was. And so if we want to compare these two, we want to know how much larger the big sphere is to the little sphere. And these were things that we found previously. This 1.05 times 10 to the 8th and the 1.58 times 10 to the 5th were the previous solutions we found. So if we want to know how much larger the surface area of the big sphere is, we're dividing these two numbers. It is about 670 times greater is what I got, or what the book got. I got like 664.56. Which means we got to multiply this bottom one by what, 670 to get to this top one is what this is kind of telling me. It's telling me how much times larger this one is than this one. Okay, and so if a single sphere had the same surface area as the total surface area of the sacs, what would be its radius based on your results? Comment on the design of the human lung. So this one is pretty similar, but now instead of working with the volume formula to find the radius, we start with the surface area to find something that has the same surface area. And so if we plug in the surface area that we previously got for the 300 million small sacs back in part A, I believe that was what, 1.05 times 10 to the 8th. And now we're back solving this thing. So we want to get r squared by itself. To get r squared by itself, it's being multiplied by 4 pi. So how would we move that to the other side? Well, if it's being multiplied, we would have to divide. So we take this 1.05 times 10 to the 8th, and we divide it by 4 pi. I simplified it out here a little bit. But we're basically getting r squared is equal to a number, and I think I said it in the previous problem. But if we got r squared is equal to a number, the way we find r is by square rooting it. And if we square root that number, that's what you should be getting somewhere out along there. And they said if it has the same surface area, what would be its radius? This would be the radius. And they want us to make a comment on the design of the human lung. And so our human lung is several of these small sacs versus one large sac. And like, why is that? Does it make sense why it's several small sacs instead of like one large air sac? Yes, no, maybe.
I'm gonna just be honest. No, I don't understand.
Okay, so this is going back to sort of like that pill thing, right? We really want a large sort of like surface area to volume ratio for our air sacs. And why do we want a large surface area to volume ratio? The surface area is where things are reacting, right? So why do we want that with like air in our bloodstream? Does that make sense?
Yes, it does.
We want a lot of air to be able to enter our bloodstream, right? And so we want a lot of like reactive spots in our alveoles or our air sacs. And so by making them smaller, it makes it more reactive. It's sort of like crushing up the pill, right? It's going to make it more reactive versus taking the whole pill. So that's basically what's happening. If we had one large air sac, it wouldn't have the surface area like these smaller sacs have. You wouldn't be able to get as much oxygen and all that good stuff in your blood. So for their small volume, they actually have a very large surface area versus something the other way around. And the last problem that we're going to go over is this channel. So the channel runs a distance of 50.45 kilometers. I don't like this problem because they tell you all this information, but they don't really give it to you very well, if that makes sense. How much earth was removed to build the entire channel? So first thing you might have to know is what volume of a cylinder. I think that might be the first thing I have on here. Pi r squared h. So you can think about this. If you look at pi r squared, that's the area of a circle. And then we're going to extend it another like dimension, which is called the height. And so if we multiply an area by another dimension, we're getting to 3 dimensions or volume. So one way you can think about this, one way that they describe these cylinders is they're like extrusions. Like, you know, those little Play-Doh things you used to get and used to like squeeze it through the little thing. It used to make the shape as it came out. If you take the area of like that face and you just multiply it by how much you squeezed out, that'd give you the volume of the object. And you like giggle a little bit because it looks like a turd. But pi r squared h. So we know that pi is 3.14 r or our radius here. So I did have to convert the kilometers to meters. But if we convert everything to meters, this should be cubic meters here. Our radius was 4, which was the height of the cylinder, or half a cylinder, so that gave us the radius. Our height of the cylinder was the length of the tunnel, which is the 50.45 kilometers. So this is giving me the volume of a cylinder, but those cylinders are not full cylinders. There are 3 of them, and they are each half. So we either have to multiply by 3 halves, or we have to multiply by 3, divide by 2. There's a few different ways to do it, but you should be getting somewhere around that number. 3.8 times 10 to the 6 cubic meters is what they have. Are there any questions about anything? I think this is it. That's the final homework problem. Yeah, that's the end of the slides. Any questions about anything? I'm gonna